Hello boys and girls, this is Mr. So. Welcome back for another lesson of biology. Today we are going through lesson 23 of chapter 14 about the seed germination. Before you start watching the video, remember to like and subscribe my channel and also share the video to your classmates. Let's start. To understand seed germination, we have to first take a look at the structure of a seed. On the outside of the seed, there is a layer called the seed coat. It protects the embryo inside from damage or attacks by the microorganisms such as the parasite, 寄生虫 or bacteria, etc. In the middle of the seed, there is a very small hole. We call it the micropyle. So it is the hole for the entry of water during seed germination. Another structure at the center of the seed we call the hilum. It is a scar left from where the seed was attached to the fruit wall, such as here. When the seed fall out, you will see the hilum. So overall, on the surface of the seed, you will see three main structures: seed coat, micropyle, and the hilum. Seed coat for protection, micropyle for water absorption, hilum as a fruit ball scar. Let's cut open the seed to look at the internal structure of the seed. There are three main parts inside the seed. You have part number one. This part is the plumule. So it has a very similar name as the Chinese meal. So that means it is actually a very small leaf. After germination, this plumule will become a big leaf. And then you have the next one. This one is the radicle. So radicle, you can find it over here. Since it starts with the letter R, so it's actually related to the root. Later on, it can be developed into a big root after germination. And then the last part, the biggest part inside the seed, we call it the cotyledon. So this is actually the food storage site for germination. How do you remember the annotation? That means the labeling. It will start with the radicle. The very small root, it will first grow out of the seed during germination. And then the middle part, cotyledon, it will grow out from the soil. At the very end, you will see the plumule. That means the leaf, they will grow out as the very last part. As you can see, the radicle first grow out as the root and then cotyledon get out. At the end, plumule grow out to form the big leaves. During the seed germination, water will be absorbed through the micropyle into the seed, and afterwards the seed coat will break. And the reason is why? Can you answer? Give you 3 seconds. This is because water, after entering into the seed, swell the cotyledon, and therefore when the cotyledon becomes bigger, it breaks the seed coat on the outside. During seed germination, the seed requires a lot of energy to grow out the root and the stem and the leaves. Where does the energy come from? It must come from the breakdown of stored food. And in the cotyledon region here, you can actually find a lot of insoluble food stored, and we call all this insoluble food starch, 淀粉. Later on, when the time is right, the starch will be broken down by enzyme. That enzyme is called amylase. With the help of amylase, starch will be broken down into some soluble food. We call that maltose, 麥芽糖. And maltose is a soluble food which can be broken down for further energy release and for the growth of the root and also the stem and the leaves. With the food broken down and a lot of energy, the plumule and the radicle, they will both grow. Plumule will become the leaves, later on radicle will become the root, and now seed germination starts. Let's take a look at the germination of a mung bean. After breaking of the seed coat, the radicle, that means the very, very small root, will start to emerge, grow out, and grow downward to form the big root. Root hair will be also formed on top of the root to increase the surface area for water absorption and mineral absorption. This picture shows a lot of root hair cells. After some day, the plant will grow upward and the cotyledon will move upward as well. And now the cotyledon is protecting the plumule tip. As you can see from this picture, the cotyledon will move upwards away from the soil, but at the same time protecting the plumule inside. Cotyledon and then will turn green and carry out photosynthesis first to make food. After some time, the cotyledon will have used up all the storage, the food, such as the starch, inside the cotyledon and become smaller and smaller, at last fall off. And at the same time, the plumule will grow out as the young leaves and able to make food by the photosynthesis, so no longer need the cotyledon. As you can see from this picture, this is the cotyledon. It's open up, and then the leaves inside the plumule will open up and grow, later on become bigger leaves. Let's take a look at the question. Name structure A and also B at the same time. What is A? A is actually the plumule, while for B is the cotyledon, where you can find a lot of stored food. And then what organ will A develop to during the seed germination? For the plumule, after some time, it will grow to become the stem and the leaf. Or you can say shoot. Both okay. Next question. During seed germination, amylase activity and enzyme activity can be detected at region B. That is the cotyledon. So can you name the function of the amylase? The amylase is actually an enzyme to break down the storage, the starch. So amylase, it breaks down or hydrolyze. Hydrolyze, that means use water to break down. Or somebody in Chinese call it 水解，用水去拆解。Hydrolyze the starch stored in the seed into maltose, 麥芽糖. And then these maltose, they are used for respiration, to release energy, for forming new cells and growth. Very important. So you got 4 marks for this question. Last question of this lesson. For the seed dry mass, that means the mass without water, totally dry. The seed dry mass drops in the initial stage, but later on, the dry mass increase. Can you explain why? Let's explain why the dry mass first drop. This is because the stored food, the stored starch inside the cotyledon, they are used up for respiration. And then why would the dry mass later on increase? Because the seedling develop green leaves. They are green in color, so they can do photosynthesis, but compare the rate of photosynthesis. Now the rate of photosynthesis is faster than the rate of respiration. That means why would it become heavier for the dry mass? Because it makes more food than using food. The rate of food production is greater than food consumption. And therefore, there is a net overall net gain of organic matter. So therefore, showing an increase in dry mass at the very end. Before you finish this lesson, you can actually go to classwork 14.1. The classwork actually includes all the questions which we have gone through in this lesson already, from question A, the naming, to question B, why you see amylase activity, to question C, asking you why the dry mass of the seedling decreased at the beginning of the germination stage, and then later on increase in the dry mass afterwards. That's it for this lesson. I will see you in the next video. Bye bye.